Okay, howdy doody. This is review set 8A question 3. There's a function given which is, it's down here, a probability density function for variable x. The interval is from 0 to 1, which I probably should have written down, but I didn't. And it says show that a equals 30 on 11. So for this probability density function to be valid, then the integral, or the area under the curve, has to give us all our probabilities adding up to 1. Right, so what that means is the integral of f of x has to equal 1. Right, now, from 0 to 1, of course, because that's where x, that's the domain for this probability function. So if I'm going to put this into an integral, I think a should come out as a constant. And then the integral, I'm going to tidy it up as well. Put the x first. You've got an x plus 1 times an x minus 1. That's an x squared minus 1, which will be a bit easier to put into the calculator. Then there's an x minus 2. The reason I'm pulling out a is so that, because the integral is just going to give me a number, it's like I'm going to have a times b equaling 1, so a will equal 1 divided by b, which they told me should be 30 on 11, so presumably to get that, my b is 11 on 30. I should have this going on. Right? So let's put this into the calculator and hopefully get 11 on 30. So to the calculator, just clear that. I get to the integral through the green alpha keys, integrating across the range of the domain of the function, x brackets x squared minus 1 brackets x minus 2 dx okay, so yeah, I think that's 11 on 30. I can go alpha f1 and do fraction to decimal here. And there's my 11 on 30. If I did the reciprocal of this, I get my 30. So 1 divided by that, you could see if you just raise it to the power of minus 1, there's a button that will do that, isn't there? Which I now, oh, here it is. Okay, so maybe just to explain that a bit more, I've got a times 11 on 30, which is what the integral gave me, equals 1. So a equals 1 divided by 11 on 30. If you like thinking about dividing fractions as the same as timesing, but flipping the second fraction, then you'll see a, it has to be 30 on 11. Or if you like, think about how could I convert that into a single number. I'd have to times by 30 so that they cancelled out, but then I'll have to do it on top as well, otherwise I'd change the fraction. Okay, so that's part 1 there. We got a is 30 on 11. That's pretty typical of a exam type question where they'll show you the answer so that you can move on to the second part of the question if you can't get it. Find the probability 0 to 0.2. Well, that's simply a matter of doing the integral in your calculator. Now, what you can do you've already typed it up here. So if you copy it, go back, this time they only want this up from 0 to 0.2, not the whole domain. And we'll have to insert in our a value or multiply it later, but I'll insert it. So second insert, and then you can put in your 30 divide 11 for a. And now you're ready to go. And we get, if we're doing 3 significant figures, 0.998, 0.0998. So that was part B of the question. The working out would just be writing out the integral, and then you could say the answer that you got, 0.0998. Let's have a look what's in part C. Find the mean of x. So if you remember, to get means, how do I get, there we are, yeah. So the mean comes from the integral of the function times x. Right? If you think of the integral of the function as giving you all the probabilities, then it's quite similar to what we saw in discrete. Right? All the possible x values across the domain 0 to 1, it's akin to this, times the sum of all the probabilities. Well, that's the integral of f of x. So there's a fairly easy way to remember that if you can remember your discrete formula. I forgot to write in 0 to 1. So I can do the same sort of thing I did before. I've already got the integral in my calculator. If I do a cut and paste from before, I'm going to have to change the 0.2 to a 1, right? So with the mean, we have to go the whole way. And I'm going to have to insert an x in somewhere. Actually, here. I can probably, I'll see if this works. No, it didn't work. Bugger. I thought I could make it an x squared, but it didn't like that. Ooh, does it like that? Let's try. It says it's a half, so it's smack bang in the middle. As far as I can tell, that's been entered in correctly. Okay, and so that question's pretty much finished then. So that worked out to be a half. Okay. So I guess the tip there is use the calculator to your advantage. Otherwise, if you're expanding everything, you're going to end up with a quintic. Once you times by x times f of x, then you're going to have to find the antiderivative, which will now be x to the power of 6 function. It's going to be a little bit laborious to do the long way.